This video is extra practice on finding derivatives of polynomial functions involving the power rule. Now before we begin, the easiest way of making this work is to first off convert your function to exponential form. Meaning when you go through each term, you want to make sure x is not in the denominator. For example, if you have a fraction where x is in your denominator, you want to turn this into a negative exponent, meaning 1 over x, x to the negative first. You want it in this form. Any radical, turn a radical into a fraction exponent. Now the way we do this is, if I'm taking the nth root of x to the m, this is the same thing as x to the m divided by n. So my root, or index, nth root, is the denominator of the fractional exponent. So what you need to do, so if in your function you have the, say, for example, the cube root of x, convert this to an exponential, x to the 1/3 power. So first thing you want to do is convert to exponential form, meaning getting rid of your fractions and your radicals. Then take the derivative, and then simplify such that your exponents are positive for your final answer, your fractional exponents turn back into radicals, and rationalize the radicals when possible. So we have three sets of problems here, 2 examples each. First example we're going to do is find a derivative in exponential form. So in exponential form, again, means no radicals, and means there are no, x is never in the denominator of a fraction. So to take the straight derivative, using the power rule, what we do for power rule is we hit the exponent times coefficient, 4 times 8, and then with our exponent we subtract 1. So 4 minus 1 is 3. Negative 3 times 4. Subtract 1 from the exponent. Negative 3 minus 1 is negative 4. Negative 5 times negative 2. Negative 5 minus 1. Then derivative of 7x is just x by itself. It turns into just 7. And the reason being why x disappears is because 7x is the same as 7x to the first power. So take the derivative. 1 times 7 is 7. And you get x to the 0. And anything to the 0 power is 1. So it's really 7 times 1, which is just 7. So that's why whenever you have a number times x with no other power besides 1, the x just goes away and 7. Derivative constant, which is 4 pi, is always 0. So derivative constant 0. Now when it is 0 like that, you don't have to put it. I'll just do it for this example here. And then that's your final answer. Again, it's in exponential form because there are no radicals and x isn't in any denominator. Okay, number 2. Okay, so same thing. Now take 7 times 1/3. When I'm multiplying a number times a fraction, 7 times third, think of the 7 as being 7 over 1. So I do numerator times numerator, denominator times denominator, I get 7/3. So 7/3 x, 7 minus 1 is 6. 6 times 2/5 is 12/5, x to the 5th, because you subtract 1. Now negative 5 times negative 14/8 will give you positive 70/8. X, negative 5 minus 1 is negative 6. Plus 2/7 comes out front. Now when you do 2/7 minus 1, as I said in class, the easiest way for doing this is taking the numerator minus denominator. So 2/7 minus 1, a shortcut would be just do 2 minus 7, which is negative 5. So it's negative 5/7. And then last, negative 5/9 times negative 3/5 is going to be positive 15 over 45. X to the negative 5/9 minus 1. So negative 5 minus 9 is negative 14. Negative 14/9. Now let's write this again neater. So what we end up getting for number 2 is y prime 7/3 x to the 6th plus 12/5 x to the 5th plus 35 fourths, that can reduce, x to the negative 6, plus 2 sevenths, x to the negative 5 sevenths, plus 15 over 45 reduces to 1/3, x to the negative 14 ninths. And that's going to be your answer. Okay, number 3. Examples now with rational functions. Okay, rational meaning our fractions. Now, what I'm going to do first is do a rewrite. I'm going to rewrite these so that it's much easier to take the derivative of and see what to do. X to the 5th over 4. I can rewrite this since our coefficient here is 1 x to the 5th over 4. If x is on top, I can push it off out front to have 1/4 x to the 5th like this. It's much easier to see what to do next. Same thing here. If x is on top, push it off. So I could have 3/7 x to the 4th minus 1/2 x cubed plus x times the cube root of 15. Okay, now it's in exponential form. Now it's going to be easy to take the derivative. So, derivative, y prime, just use your power rule. 5 times 1/4 is 5/4. X minus 1, so x to the 4th. 4 times 3/7 is 12/7. X to the 3rd. 3 times negative 1/2 is negative 3/2 x squared. Now here, I have x times the cube root of 15. If you put cube root of 15 into a calculator, this is going to be a number. It's really a number times x, which we see up here for number 1. The derivative of a number times x is just a number. So the derivative of a number times x is just a number. X goes away. So I have plus the cube root of 15. Now, to make sure it's in the simplest form, what I'm going to do is make sure all my exponents are positive, which they all are. So this is going to be my final answer. Now, if you wanted to, it's up to you. This is fine. Or you could have your answer like this. If x is ever up front, you can put it up top. This works as well. This is equivalent. So again, x can be out front or in the numerator. Numerator out front. Okay, number 4. Okay, now again, rational functions. This time I have x in my denominators. So I have a bunch of fractions. I will get rid of that because it's harder to take the derivative this way. It's a little bit more tedious, a little bit more work. But if I convert it to an exponential function, it's much simpler. So what I'm going to do is, to eliminate the fraction, each term in the denominator, I'm going to put it up top in the numerator and make it a negative exponent. So I'm going to rewrite this as y equals 5x to the negative 3 minus 12x to the negative 2 plus 4x to the negative 1 plus 4/11 x to the negative 7 minus 2/3 x to the negative 9. I'm running a little space here, but I have plus the square root of 5 x to the negative 4th. And again, the square root of 5 is my coefficient for x, plus 8 pi. So now I rewrote it as an exponential function, so that I can now take the derivative easily. So y prime, negative 3 times 5, negative 15x, negative 3 minus 1, negative 4, negative 2 to negative 12, x to the negative 3, Negative 1 times 4. Negative 4x to the negative 2. Let's draw a divider here. Negative 7 times 4 elevenths. 7 times 4, so it would be negative 28 elevenths. X to the negative 8. Negative 7 minus 1. Negative 9 times 2/3. X to the negative 10. Negative 4 times the square root of 5 would just be minus 4 square roots of 5. X to the negative 5th. And then the derivative of 8 pi is going to be 0 because 8 pi is a number, it's a constant, derivative is nothing. So just to recap, I have x in my denominator, I changed to negative exponents, so I can do a simple power rule for my derivative, and that's it, done. Now the only thing is, to simplify this, instead of having negative exponents, I want to have positive exponents. So I'm going to do a rewrite of my answer. So y prime, instead of negative 15 x to the negative 4th, negative 15 over x to the 4th. Actually, I'll rewrite it here. Plus 24 over x cubed minus 4 over x squared minus, now 28 over 11, x to the 8th in the denominator. (18/3) is 6, but x to the 10th goes in our denominator. And then I have minus 4 square roots of 5, x to the negative 5th. Again, this is our coefficient. X to the negative 5th, so x to the positive 5th in our denominator. And now this would be my final answer. So this answer is technically correct, but this is more simplified. Okay, number 5. Now some examples with radicals. Okay, now again, in order to take the derivative of a radical, we're going to convert it to exponential form, like the fractions, do our derivative, and then convert it back to radicals again. So again, our steps, we're going to convert to exponential form, derivative, convert back to radicals, and simplify. That's our steps. So first thing, let's convert these to exponentials. So I have x. So the 7th root of x to the 4th is going to be x to the 4/7 power plus x to the 3/5 power plus 10x is the 4th root of x, so x to the 1/4 minus 3 x to the 1/2 plus 4e. Okay, so step 1 is done. Convert to exponential form. There's no fractions, like x is in any denominator, and all radicals are gone. So I have a simple power rule for my derivative. So now 4/7 comes out front. 4/7 minus 1. Again, 4 minus 7 is negative 3. Plus 3/5 comes out front. 3 minus 5 is negative 2. So again, this is a simple way of subtracting 1 in your head. 1/4 times 10 is 10/4. 1 minus 4, negative 3/4. 1/2 times 3. Now the derivative of 4e, as we talked about in our logarithm unit, e is a number. So 4e is a number, so the derivative of a constant is going to be 0. So I did my derivative. Now I have a bunch of fractional or rational exponents, so we're going to convert them back into radicals. Well, first I'll convert back to radicals, and also we need to have positive exponents. So I'll first do positive exponents. So I have 4/7. These are all negative, so they're going to go into denominators. if you just follow this step every single time, this will work out for you. Okay, and now convert back to radicals. This is the 6th root of x to the 3rd. Fifth root of x squared. 10/4 is 5/2. 4th root of x cubed. Square root of x. Okay, so here's our derivative. Now from here, in this step, y prime. From this step, what we can do is we can do something called rationalize our denominator. And rationalizing means basically get the radical out of the denominator. So from Algebra 2 and pre-calculus, remember, if you have a square root of a number, what we did was we multiplied both top and bottom by the square root of that number. So in this case here, I multiply by top and bottom by square root of x over the square root of x, and what you're getting is 3 square roots of x on top, 2 square root of x times square root of x is just x. So now again, there's no radical in our denominator. Now for the second one, in order to do this, I need to have a matching index. So I'm going to multiply both top and bottom by the 4th root, and in order to do this, to get rid of the radical, I need the exponent to match the index, because the 4th root of something to the 4th is just the inside. So since I have 3 x's here, I need one more x to make 4. I'll put one more x in there. So by multiplying top and bottom by the 4th root of x, I have 5 4th roots of x over 2 4th root of x cubed times the 4th root of x is just going to be x. Okay, plus, now here again, get rid of the radical. I need 5 x's because the 5th root. So I'm going to multiply the 5th root of, I have 2 already, I need 3 more. So x to the 3rd. So 5th root of x to the 3rd. So you have, so again, 2 and 3 gives you 5. So I have 3 5th roots of x cubed over 5 x. And then this one, I need 7, so I'm going to multiply top and bottom by the 7th root. I need 7 x's, I have 3, so I need 4 more. So I have 4 7th roots of x to the 4th over 7x. And you get here. So we can simplify a little bit further yet, getting a common denominator, and then you can add numerators together and so on. But I'm going to leave it at this point for now. Just this is good enough as long as you're able to rationalize your denominators. Okay, last one, number 6. Okay, we'll follow the same steps here. So now in this case, I have to convert this to exponential form. Now I have radicals and fractions. So what I'm going to do first is convert my radicals into exponents. So I'm going to do a rewrite. So I have negative 1 over x to the 1/5 plus 5/2 x to the 3/4 minus 12/7 x to the 2/3 plus 4/5 x to the 1/2 minus the square root of 7. Now square root of 7, I'm not worried about that one because, again, it's just a number. So its derivative is going to go away. Okay, now I'll convert these to exponents, negative exponents. So I'm going to do another rewrite. So y equals negative x to the negative 1/5. Because I have negative 1, I'm going to bring this up top. Plus 5/2 x to the negative 3/4 minus 12/7 x to the negative 2/3 plus 4/5 x to the negative 1/2 minus the square root of 7. Okay, now it's an exponential form. There are no radicals, and the fractions are eliminated. So my derivative, okay, these are a power rule. Negative 1, so I have positive 1/5 x to the negative 6/5, because negative 1 minus 5 is negative 6, minus 15/8 x to the negative 7/4 plus 24/21 x to the negative 5/3 minus 4/10 x to the negative 3/2, and then the derivative of the square root of 0, square root of 7 is going to be 0. Okay. From here, so our derivative is done. Now let's convert this back to radicals. So I'm going to make all of my negative exponents positive. So I'll rewrite. So 1 over 5 x to the 6/5 minus 15 over 8 x to the 7/4 plus 24 over 21 is going to be 8/7 x to the 5/3 minus 4/10 2/5 x to the 3/2 minus 0. I'm not going to write that anymore. So now I have fractions. Now I'm going to make these exponents are positive. Now I'm going to make it back into radicals. So I have y prime 1 over 5, the 5th root, x to the 6th, minus 15 over 8, the 4th root of x to the 7th, plus 8/7, the cube root of x to the 5th, minus 2/5, square root of x cubed. Okay, now these can now it's back in radical form. It's in radicals. So simplify a little bit further. X to the 6th inside of 5th root. So I can have 1x come out. And you get to this point, and then from here, you would rationalize your denominators for these radicals, just like you did in the previous problem, where you multiply top and bottom by the same root, so that they match, and x is radicals out of the denominator. So this is off right here. I'm going to do a rewrite. Okay, so this is the problem we had on our line. So now, in order to get rid of my radical denominator, in this one here, I'm going to multiply both top and bottom by the square root of x. So what I get for our last final term is 2 times the square root of x divided by 5x square root of x times the square root of x is going to be x. So 5x times x gives me x squared. In this case here, in order to complete this radical, I'm going to multiply top and bottom by the cube root. I have 2 x's, I need 3 altogether, so I'll put one more x in there. So now x squared times x is x to the third, cube root of x to the third is just x. So now I have an x here, and together this gives me a second one, so I get 7x squared, 8 cube roots of x up top. Okay, this one here, I have 3 x's, I need one more to complete this radical, so I'll multiply by one more, so the 4th root of x, 4th root of x, so I have negative 15, 4th root of x, over 8, I already have 8x, this adds another x, so 8x squared, and now in this case here, x to the 5th root of x, so I need 5 x's total, so I'll multiply by 5th root of x to the 4th, and I get 5th root of x to the 4th. So you get, the last piece you can do if you want to keep going with this is you can get a common denominator, which would be x squared, and then the common multiple of 5, 7, 8, and 5, and then manipulate your numerators. But otherwise, this gets us rationalized so that there's no radicals in our denominators.